So in today's lecture, we are going to start the relative motion. So relative motion can be divided in two parts, the relative motion in one dimension and the relative motion in two dimension. So first we will discuss the relative motion in one dimension, right? So relative motion in 1D relative motion. You may write the heading 1D relative motion or the relative motion in straight line only. Is it clear? So to understand this, suppose we have, this is the x-axis, this is the car A, all right, and on the straight line the car B is over there and it is moving like this. So this is the velocity of the car A, this is the velocity of the car B, right? These velocities of car A and B are with respect to ground, right? That is, you are sitting here on the ground and you are watching this, right? So the velocity of the car A may be written as VA I cap, right, because they are moving, and velocity of B may be written as VB I cap. Is it clear or not? Suppose the distance from the origin of this car is A and the separation from the origin of this car B is B. So the VA may be written as dxa upon dt and VB may be written as dxb upon dt. Is it clear or not? Are you getting? So these are the velocities with respect to ground. Are you getting? With respect to ground. Now if you sit on A and observe the B, right, or when you sit on the B and observe A, is it clear or not? So the velocity of B, right, the velocity of B with respect to A, velocity of B with respect to A, what does it mean? The velocity of B with respect to A mean you are sitting on A and observing the B. So it is represented by velocity of B with respect to A, and the velocity of B with respect to A is VB minus VA. Is it clear or not? VB minus VA. Fine. This is the velocity of B with respect to A. And what is the velocity of A? Velocity of A with respect to B, right, is equal to velocity of A with respect to B. It means you are sitting on B and observing the A. So VA comma B is equal to velocity of A minus velocity of B. Velocity of A is equal to what? This is VB I cap minus VA I cap. Is it clear? And VA comma B is equal to what? VA I cap minus VB I cap. Is it clear? Although I have written this velocity in terms of I cap, right, like this, but when we will solve, we will take the shortcut to solve this type of the question, right? For example, I am giving an example. Suppose this is the car A and it is moving with 50 meter per second, right, or 50 kilometer per hour, you may write. Fine. And the car B is moving in the same straight line and the speed is 80 kilometer per hour. Is it clear? This is 50 kilometer per hour and this is 80 kilometer per hour, right? Or you may interchange, it is 80 kilometer per hour, it is 50 kilometer per hour. Is it clear or not? So these are the velocity with respect to ground. Now you have to find velocity of A with respect to B, and first velocity of B with respect to A and then velocity of A with respect to B. These velocity you have to find. Okay, so how to solve this? Listen one thing. When you have to find the velocity of B with respect to A, velocity of B with respect to A mean you are sitting on A. You are sitting on A. When you are sitting on A, right, it is assumed to be rest, right? And then what is the velocity of B? It would be found with the help of the equation VB minus VA. What is the VB? What is the VB? The VB is 50 I cap. Assume this is the x direction. minus VA. What is VA? It is 80 I cap. Answer is minus 30 I cap. Minus 30 I cap mean, although this is the figure with respect to ground. Now, if the figure you want to make with respect to A, so you are sitting on A and observing the B. So the velocity of B with respect to A is minus 30 I cap mean, with respect to A, the B is coming towards A with the speed 30 km per hour. Is it clear or not? You tell. Right? That is the thing. Listen, one more thing. This is the first part. And the second part, velocity of A with respect to B. How to find? This is VA minus VP. What is the VA? You will say it is 80 I cap minus VB. It is 50 I cap, because it is both are in same direction. So what is the answer? Say 30 I cap. Right, kilometer per hour. Here also you may write kilometer per hour. So if you make the figure with respect to B, with respect to B mean you are sitting on the B and observing the A, right? So what is its velocity? Its velocity is 30 km per hour towards the B. It is at rest and the B is A is coming towards this and it will collide. While when you are sitting on A, the B is coming and it will collide with A. You understand this thing or not? Right. Suppose the distance, initial distance, the separation between them is the 60 kilometer. Is it clear or not? The 60 kilometer. So also find, you may write, also find when they will, also find the time when they will collide, right? They will collide. So then how to find the time? Tell me. By any of the two figures, whether this, you may assume this is the time of the collision we can find with the help of the relative motion. It is at rest and it is coming. By what velocity it is coming towards A? You will say 30 km per hour. And what is the separation? Say 60 km. So when the car is coming with some speed, the distance is given, the speed is known. So can you find the time? Yes. Simple formula. S is equal to U, time is equal to distance upon the speed. What is the distance it has to cover? Say 60 km. By what speed it is coming? Say 30 km per hour. So what is the answer? Say 2 hours. So after 2 hours, they will collide. Is it clear or not? In the same way, if B, you are sitting on B and it is coming toward this, what is the separation? Initial separation is 60 km. The same formula you will apply, and after 2 hours, the car A will collide the car B. Is it clear? Copy this. So this is the question we have done, right? We can find the another trick to solve this question, right? And what is that? Listen, one thing, short trick I am telling you, right? For example, suppose this is the car A, right? And this is the car B. It is moving with 80 km per hour and it is moving with 50 km per hour. Both are moving with respect to ground, Is it clear or not? Although this is done by I cap and J cap. Now if you want to make the figure with respect to A, mean you are sitting on A and you are observing the car B. So what to do? To find the relative velocity of B with respect to A, what you will do? You will sit on A and transfer its velocity to the B in opposite direction. Suppose, what is its velocity? Say 50 km per hour. What is its velocity? Say 80 km per hour. So transfer this velocity to B in opposite direction. And how much it is? It is 50 and it is what? 80. I am writing here. This is the 50 and transfer this velocity to be in opposite direction. This is the 80 km per hour, right? So what is the resultant of these two velocity? Tell me. 80 minus 50, 30 km per hour. Is it clear or not? In the same way, you can find the velocity of B, velocity of A with respect to B, velocity of A with respect to B. With respect to B mean you are sitting, right? You are sitting on B. It means it is assumed to be rest. This is A, right? Although the velocity of A is what? It is 80. So what you have to do? To find the relative velocity of A with respect to B, transfer this velocity to A, but in opposite direction. So it is 50 km per hour. So can you tell me what is the resultant? 80 minus 50, 30 km per hour. Is it clear or not? So this is the figure with respect to B. Is it clear or not? Listen, one more thing. Few more examples. For examples, suppose this is the car A moving with 20 km per hour, and this is the car B moving towards this, and this is the 10 km per hour. Are you getting or not? Suppose the 60 km is the initial separation. So when both are moving towards each other, they will collide or not? They will collide. So what you have to find? Find time when they collide. When they collide. This is the question, right? Copy this and try. So how to solve this question, you tell. You have to find the time. So either you choose A or B. You can sit on either on A or B. You tell me on which car we should sit. Suppose I'm sitting on the car A, right? With respect to A, I'm making the figure. So if you are sitting on A and you are observing the B, getting or not? So what is the velocity of B, you tell? It is 10 km per hour. Is it fine? And to find the relative velocity of B with respect to A, so you will transfer this velocity to the B, but in opposite direction. So 10 km per hour is velocity of B already present, and this velocity is also transferred 20 km per hour. So 20 plus this is 20 plus 10 km per hour. So what is the velocity of B with respect to A? 30 km per hour. And what is the distance? A. So although they are moving, both are moving with respect to ground, but with respect to A, it will look like that B is coming towards A with the speed 30 km per hour, and this is the 30 km is the separation. So S is equal to UT. So time is equal to distance upon speed. What is the distance? 60. What is the speed? Say 30. So 2R. After 2R, it will collide. What is 30 km per hour? This is the velocity of B with respect to A. We have found, right, which is 30 km per hour towards A. Copy this. So listen one thing. By this calculation, we can conclude that if the two cars or the two bodies are moving in the same direction, as they are moving in the same direction, so in same direction, the relative velocity is what? The relative velocities are subtracted. So 80 minus 30, right? The relative velocity is what? Say this is 50, right? Like this. This is the 50 and this is 80. So they are subtracted when they are moving in the same direction. When they are moving in the opposite direction, the relative velocity is found by adding these two velocities. So in the same direction, the velocities are added. If they are moving in the same direction, the relative velocity is the addition of the two velocities of the two cars. If they are moving in the same direction, the relative velocity is the difference of the two velocities, right? So you can conclude this and you can memorize. If both are moving in the same direction, subtract them. If both are moving in opposite direction, you can add them, right? But the short trick what I told you, it is very important, and the relative motion in the plane can also be solved, like Rainman problem, the river boat problem, right? Boat river problem. All the problems can be solved by this short trick. What you have to do, with respect to which you want to find the velocity, relative velocity, sit on that and transfer the velocity to the other object in opposite direction and find the resultant, right? So this is the solution. Copy this. So in this question, the two buses A and B are moving in the same direction with the speed 20 meter per second, 15 meter per second. Find the relative velocity of A with respect to B and relative velocity of B with respect to A. Although in this question the direction is not given, right? So I will assume this is the car A and it is moving with the speed 20 meter per second. This is the car B moving with the speed 15 meter per second. Getting or not? In the same direction they are moving. So this is the figure with respect to ground. Is it clear or not? Now the first part, you have to find relative velocity of A with respect to B. This is the relative velocity of A with respect to B mean. With respect to B mean, you are sitting on B and observing the A. So it is at rest. This figure is with respect to B. Is it clear or not? So what you have to do? This is the velocity. To find the relative velocity with respect to B, transfer this velocity to A in opposite direction. Right, like this. Suppose this is the A. It is moving itself with 20 meter per second. Transfer this velocity to A in opposite direction. Right, it is 15 meter per second. What is the resultant? 20 minus 15, 5 meter per second. So this is the relative velocity of A with respect to B. Second, if you want to find the relative velocity of B with respect to A, right, with respect to A mean, you are sitting on A and therefore it is at rest. So this figure is, say, with respect to B. This figure is with respect to ground, because with respect to ground both are moving. So now if this is the B, although B is moving itself 15 meter per second, now transfer the velocity of A to B in opposite direction. This is 20 meter per second. What is the resultant? 20 minus 5 meter per second. So this is the answer. So velocity of B with respect to A is 5 meter per second, right? And velocity of A with respect to V is also 5 meter per second. Is it clear or not? And the direction is shown figure, right? Copy this. So in this example, Delhi is at a distance 200 km from Ambala. Car A set from Ambala. Speed is 30 km per hour, and the B set out at the same time from the Delhi and the speed is 20 km per hour. They are asking when they will cross each other and what is the distance of that point from the Ambala, right? So in this example, suppose this is the D for Delhi and A for Ambala, right? The separation between them is 200 km. Fine. This is the car A, fine, and its speed is what? 30 km per hour. This is A for Ambala, right? Here D for Delhi, and this is the car B. At the same time, the car B is 20 km per hour. Is it clear or not? So when they will cross each other, what is the distance of, suppose this is the point, right, where they will cross each other. So although we can do this question without relative, but now we have to use the concept of the relative motion. Is it clear or not? So when they will cross means when they will meet. To find that thing, right, find that thing, make the figure with respect to B. You are sitting on B. With respect to B, if you are making the figure, then it is at rest, right? With respect to B. So can you tell me what will be the relative velocity of A with respect to B? Relative velocity of A with respect to B, we are going to find. So easy way. What is the easy way? I told you, although it is moving with 30 km per hour, right? To find the relative velocity, what you have to do? Transfer this velocity in opposite direction. So it is 20 plus. So what is the relative velocity of A? Say 50 km per hour. So it means it is at rest. The car A is coming towards B and they will meet. So what is the time? So distance is 200 km. So the S is equal to ut. Time is equal to distance upon the relative speed. The distance is 200. The relative speed is 50 after 4 hours. So the time after 4 hours, they will meet somewhere. Is it clear or not? So can you find this distance x? It will move like this. It will move like this. So after 4 hours, they will move at this point. They will meet at this point. Is it clear or not? So this distance we have to find. To find this distance x is equal to u into t. Right? Distance is equal to speed into time. What is the speed of the car A? Say 30. What is the time? Say 4. So x is equal to what? Say 120 kilometer. Right? This is 30 kilometer per hour into 4. So from the Ambala, the 120 kilometer, right, at distance, both car will move like this. If this is D for Delhi, this is the A for Ambala, and this is the 120 kilometer. From Ambala, the both car will move, and this is what? Say 80 kilometer. This is the car B, this is the car A. And what is the time? After 4 hours. So without using any I cap or J cap, right, you can solve by short trick the relative questions, right? Copy this. So in this illustration, two trains A and B, which are 100 meter and 60 meter long, moving in opposite direction in the parallel track. Velocity of the shorter train is 3 times that of the longer one. If train take 4 seconds to cross each other, find their velocity of the train, right? So this is a very good example. And how to solve this question? Listen one thing. Suppose this is the long train, right? And this is the train A, the 100 meter. Fine. On the other track, the shorter train, the B train, the 60 meter. According to question, listen one thing. According to question, the velocity of the shorter is 3 times the velocity of longer. If I assume the velocity of A is VA, and therefore the velocity of shorter is 3 times, so its velocity is 3v. Is it clear or not? Its velocity of the shorter is 3 times that of velocity of A. Now, it take 4 seconds to cross each other. Find the velocity. Listen, what is the meaning of the crossing? First of all, you understand. Listen, although they are moving like this, they are moving like this, right? And they are crossing each other, right? So what will you do? You sit on the A. Either you may sit on the B, but now this is the figure with respect to what? With respect to ground. Can you make the figure with respect to A? Yes. With respect to A mean you are sitting on A, right? And it is at rest. Is it clear or not? You tell. Now, with respect to A, right? Can you find the velocity of B? Yes, it is very easy. How to find? This is the 3B, and transfer this velocity in opposite direction. This is 3B plus B. So what is the velocity of B with respect to A? It is 4B. Is it clear or not? So therefore, the car is coming, the car B It is at rest. Assume it is at rest and the car B is coming like this. So when the crossing will start, the crossing will start when the B reaches at this point. Is it fine? And what is the velocity? Say 4p. And it is at rest. We are making the figure with respect to A. So velocity of B with respect to A is 4b, and it is moving like this. It is at rest. It is moving with 4b. It start crossing. Right? It is coming from long, far away, and when it reaches, now the crossing is start. It is at rest. It is moving like this. And when the car B reaches at this point, now you will say it is continuously moving with the speed 4b. You will say the crossing is finished. So tell me, what is the time from this point to this point moving in this by the car? So according to the question, the total 4 seconds are taken. All right. And what is the distance? Say 100 meter, the car A, and this is how much? The 60 meter. So what is the total distance covered by the B? 160 meter. Right. So S is equal to UT. I can apply. What is the distance? Say 160. Why? What speed they are moving? By what speed the B is moving? 4b. Time is 4 seconds. So the B is equal to 160 upon 4 just 16. Right. It is 10. So velocity B is 10 meter per second. Is it clear or not? Therefore, what is the velocity of A? The velocity of A is equal to V, which is equal to 10 meter per second. And what is the velocity of B? The velocity of B is what? 3V is equal to 3 into 10, 30 meter per second. Right. So this is the solution. I think you are getting this. Copy. There are two trains A and B, each of length 50 meter, are moving with constant speed. If one train A overtakes the other in, right, 40 seconds while crosses the other in 20 seconds, find the speed of each train. So in this solution, suppose this is the train A and the length of the each train is 50 meter, and this is also the length of the train B is the 50 meter. Is it clear or not? Assume the velocity of A, the velocity of B, right? So the overtakes the other into 40 seconds. Overtakes mean, listen one thing, overtake mean this is A, this is B, right? B is moving in the same direction with the speed VB, right? And therefore they overtake. Overtake mean you can sit on B, right? You can sit on B. If these are the velocities of A and B, although this is the 50 meter, this is the 50 meter. This is the figure with respect to ground. With respect to ground, both are moving in the same direction. Now, this is the car A and its overtake. Therefore, its velocity will be greater as compared to B because it is overtaking. So, to find this, what you have to do? You sit on the B. Now, with respect to B, you have to make the figure. That is, you have to find the velocity of A with respect to B. Can you tell me what is the velocity of A with respect to B? With respect to B, right, you have to make figure. This is the velocity of A. And to find the relative velocity transfer, you are sitting on B, transfer the velocity of B to the A. So it is VB and it is VA. Right. Assume this is A, this is the VA and this is the VB. So what is the resultant velocity by which the car is coming? The answer is VA minus VB. Is it fine or not? You tell. So in overtaking, when the overtaking takes place, when the car reaches at this point A, what is the speed? Right. In overtaking, the speed is VA minus VB and it start at t is equal to 0. at t is equal to, after some time, right, the car A overtakes the B. Is it clear or not? What time it takes? In 40 seconds. So you tell me, what is the distance covered? The length is 50 meter and this length is also 50 meter. So what is the distance covered? Say 100 meter. By what velocity it is covered? The relative velocity is VA minus VB. So S is equal to UT. The distance is 100. VA minus VB. And the total time is 40. Fine. From here, VA minus VB is equal to what? 100 upon 40 is equal to 5 by 2. Right. VA minus VB is equal to 2.5 meter per second. So this is the one equation when the car A is overtaking the car B. Is it clear? Copy this. So now listen one thing. This is the case when the car A overtakes the car B. Now how this car will cross the car B? Suppose this is the car B, right? It is moving with the speed VB and the car A is moving in this direction with the speed VA, right? And what time it take to cross? 20 seconds. So now you will sit on the B, right? This is the figure with respect to ground. Can you make the figure with respect to B? Yes, I can make with respect to B, right? You are sitting on this, so it is at rest. So which is moving? Say the car is moving. Can you tell me what is the relative velocity then? Transfer this velocity to the A, therefore the velocity becomes VB plus VA. Now this car is coming towards B and it will cross like this. What is the velocity by which it is coming? The relative velocity is VA plus VB. Also you can say when both are moving in opposite direction, the relative velocity is increase. Fine. So this is the A. The car is crossing start at this point. When the car reaches at this point, right, so the crossing is finished. Fine. So what is the distance covered in crossing this? 50 meter, and this is the 50 meter. 50 plus 50, 100 meter. By what speed they are crossing? VA plus VP. So again, S is equal to UT, distance is 100, VA plus VB into time is 20. So VA plus VB is equal to 100 upon 20 is equal to 5. So this is the second equation. This is the one equation, this is the second equation. Now you can simplify both and you can get the answer. And VA minus VB is equal to 2.5. VA plus VB is equal to 5. So if you add them, 2 VA is equal to 7.5. VA velocity is 7.5 by 2, 3.75 meter per second. All right. And what is the velocity of B? VB is equal to 5 minus VA. 5 minus VA. VA come this side. 3.75. 1.25 meter per second. So this is the velocity of B and this is the velocity of A for this question. Right? Copy this. So in this question, two cars approaches each other on a straight line or straight road with velocity 10 meter per second, 12 meter per second. When they are 150 meter apart, they apply the brakes and the retardation is produced of 2 meter per second square until they stop. So they are asking how far they will be when both come to halt, right? Although this is the questions given here, right, without relative motion we can also solve this. This is the car A, 10 meter per second. This is the car B and 12 meter per second. Right, initially the 150 meter is the distance between them. The retardation is right. The velocity become 0. So can you find the x1? The retardation is minus 2 meter per second square. In the same way, after traveling some distance, this velocity become 0, and this distance is covered x2. So can you find the x1 and x2? Yes. V square is equal to u square plus 2as. Final velocity is 0. The initial is 10 square minus 2 into x1. So 100 is equal to 4x1. x1 is equal to 25 meter. So this is the distance covered by the car A before halt. And what about this? The v square is equal to u square plus 2as again. Final speed is 0. The initial is 12 square. The acceleration is minus 2 because the 2 meter per second is the retardation. So this is the x2. This is 144 is equal to 4x2, right? This is the 12 square. So x2 is what? 44 upon 4. 4 tiya 12. 4 24. x2 is 36 meter. Are you getting? So this distance is 36 meter. This distance is 25 meter. So what is the separation between them? Can you find? Yes. So the separation between them, d is equal to 150 minus x1 plus x2. 150 minus 25 plus 36. 150 minus 11 into 6. 150, 61, 9, 89 meter. So the separation between them will be 89 meter when both are stopped, right? Copy this. So in this question, the two trains A and B of length 400 meter each are moving towards two parallel track with uniform speed 72 km per hour in the same direction. A ahead of B. The driver B decide to overtake A, accelerates by 1 meter per second and take 50 seconds. The guard B just brushes past the driver of A. What is the original distance between the guard of B and the driver of A? Right. Okay. So in this question, we have this is the train A. All right. And this is the driver of train A. Right. Here it is the driver of train A. And suppose the train B is behind of the train A, right? And this is the driver, between the driver guard of B and this is the guard, right, of B. This is the driver. Is it clear or not? Both are moving with the same speed. The initial speed is what? 72 km per hour. 72 km per hour means 72 into 5 by 18, right? This is 4, it is 20 meter per second. So initial speed is 20 meter per second. Both are moving on the same parallel track. All right. So the distance D we have to find. So to overtake the train A, what we have to do? B have to accelerate, right? So what we have to do? This is the figure with respect to what? With respect to ground. So with respect to ground, both car or both trains are moving in the forward direction, right? In the forward direction. So can you make the figure with respect to A? Yes. If you make the figure with respect to A, right, it means the driver of A, right, this is the driver of A, seeing the driver of B. Is it clear? Seeing the guard of B. Is it clear? So I'm making with respect to A. So it will be at rest. Are you getting or not? And it is at rest, and therefore, what is the initial relative velocity? It is 20, and this velocity is transferred to this. So the 20 meter per second. So what is the initial velocity of the car B? Initial velocity of car B or the train B with respect to A is what? 20 minus 20 is 0. Now what is the acceleration? Its acceleration is 0 and it accelerate. What is the acceleration? Right. The acceleration is, what is the acceleration? 1 meter per second square. So this is the relative acceleration. So this car is coming towards A. with the acceleration a, and after some time it start from here, it is t is equal to 0. So when it pass this train, it is at rest, and the car A is moving, car B is moving in this way. Are you getting? Initial velocity, there will be some velocity, fine, and it take 50 seconds. Is it clear or not? So in 50 seconds, it cover the distance s. So this distance we have to find. I can apply s is equal to ut plus half at square. What is the initial relative velocity? Say 0. And what is the relative acceleration? Say 1. Because the acceleration of the A is 0, right? It does not have any acceleration. And what is the time? It is 50. So how much it is? 1250 meter. So the initial separation between the driver of A and the guard of B, initial separation is 1250 meter, right? This is the answer. Copy this. So in this example, you can read, boy standing on a stationary lift, throw a ball upward with maximum initial speed 49 meter per second. How much time it will take to return his hand? Initially, suppose this is the lift, the boy is standing right on the lift, and this is the ball, right, and he throw this ball with the u, speed u, and it come back to its hand. Are you getting or not? So the time is what? Say 2u upon g. Is it clear or not? So the initial speed is 49 meter per second, and the g is 9.8. So 98 divided by 9.8. So time taken is what? Say 10 seconds. Is it clear or not? Suppose this is the lift at rest. Fine. This is the thing. Now, if this, suppose this lift accelerate, or if the lift start moving up with the uniform speed 5 meter per second, it means the acceleration of the lift is what? 0, and it is moving with the speed 5 meter per second. Is it clear? So, although this is the question for the pseudo force, right? So, with respect to lift, right, when you throw with the speed, the speed of the lift is 5 meter per second, but with respect to lift, it throw with the same speed. Are you getting or not? Although after some time, the lift will move up, right, at some distance, but with respect to lift, the speed will be this, and now the ball is come to its hand 49 meter per second with the same speed with respect to lift. With respect to lift, there is no change in the throwing this ball, right? So again the time will be 2u upon g. With respect to lift, the speed will be same, 49 it is, right, upon 9.8 and the 2 second. So again, the time will be the 10 second. So if it is moving with the same as zero acceleration, whatever the velocity or the speed of the lift is, the acceleration of the lift is 0. With respect to car, the g effective in this case will be equal to g, and there is no change in the time of flight, right? Copy this. So now we do some questions on the relative motion in 1D, relative motion in one dimension. This is the very special case, right? Although in the previous question, for example, this is the car A, it is moving with 10 meter per second, and the car B, right, it is moving in 20 meter per second. So what is the relative velocity when both are moving towards each other? 10 plus 20, the 30 meter per second. Is it clear or not? This is the case when the speed or the velocity of the car A and B are given with respect to ground. But the thing is different in this question. Suppose there is a train, right, and this train velocity is in forward direction, suppose 50 meter per second, right, and there is a person or the monkey, you can assume. Now this is the monkey, right? Monkey runs on the roof of train, right, with velocity or with speed 20 meter per second, right? First, in the direction of, in the direction of motion of train, direction of motion of train, right? Second, in opposite direction of motion of train. Are you getting or not? You have to find velocity of monkey, velocity of monkey with respect to ground, right? In each case, this is the question. All right, copy this. So this is the questions. In this case, the monkey is running. So how to solve this question? You tell. Listen one thing. In the first case, right, this is the velocity of the train, right, with respect to ground. Velocity of train with respect to ground is what? 50 I cap. You can write it is the x direction. In this case, the monkey on the train is moving, right, in the direction of the, with respect to, monkey runs on the roof of the train with velocity 20 meters per second. With respect to train, you have to write, right, with respect to train. In the, with respect to train mean it velocity is given in this direction. Velocity of monkey with respect to train is, in the first case, 20 meter per second, that is 20 I cap meter per second. It is clear or not? So both are moving. Then we have to find the velocity of monkey with respect to ground is nothing but velocity of monkey with respect to train plus velocity of train with respect to ground. Is it clear or not? So when in this case, suppose if the two cars are moving, suppose this is the 10 meter per second, suppose this is 30 meter per second, and this is 5 meter per second. When both are moving in the same direction, what is the relative velocity? Say 30 minus 5 is equal to 25 meter per second. But in this case, it is moving in the same, both are moving in the same direction. But in this case, the velocity of the monkey is given with respect to train, which is 20 I cap, right, plus this is 50 I cap, 70 I cap. It means with respect to train, the velocity is 20 I cap, but with respect to ground, if we see from the ground, right, with respect to ground, the monkey is moving with the speed 70 meter per second in the forward direction. Is it clear or not? In the second case, when the train is moving, right, velocity of train with respect to ground is 50 I cap, and the monkey is moving with respect to train, velocity of monkey with respect to train in the opposite direction, this is minus 20 I cap. So how to find the velocity of monkey with respect to train? Tell me, with respect to ground, monkey with respect to train plus velocity of train with respect to ground. Monkey with respect to train is minus 20 I cap. The train with respect to ground is 50 I cap. So this is 30 I cap meter per second. It means with respect to ground, the monkey is moving. Monkey is appear to move with the speed 30 meter per second in the forward direction. While, listen one thing, in this case, when both are moving in opposite direction, the relative velocity is added. But in this case, the train is moving and the monkey is moving in the opposite direction, right? But this velocity is nothing but monkey velocity with respect to train. Here, these are the velocity of A with respect to ground. This is the velocity of B with respect to ground. So this case is different. When the velocities are given with respect to ground and they are moving in opposite direction, the relative velocity is added, right? Velocities are added to get the relative velocity. When they are moving, this is the A, this is the B. This is the velocity of B with respect to ground. This is the velocity of A with respect to ground. So when both are moving in the same direction and the velocities are given with respect to ground, they are subtracted. This case is different. Here the velocity of the monkey is given, velocity of monkey is given with respect to train. Then we will use this vector equation. Is it clear or not? Although this is the method by solving, this is the method solving using the vector equation. But without vector in the short trick, we can also solve this question. How? Let's see. Listen, suppose this is the train, right? It is moving what, the first case, it is moving with what speed? Say 50 meter per second. And the monkey is over there. Although, suppose the train is at rest. So monkey is moving with 20 meter per second. And if you are standing on the ground, it is at rest. So with respect to ground, what is the velocity of the monkey with respect to ground? Same, it is at rest. So it will continue to move with 20 meter per second. But when the train is also moving in the same direction, so what will be the velocity? Say 20. Also the train is moving in the same direction. This is the 50 meter per second. So what is the answer? Say 70 meter per second. Is it clear or not? Like this. In the second case, what is the second case? Suppose this is the train. You can assume it is at rest and the monkey is moving with the speed 20 meter per second in opposite direction. So with respect to ground, if you are standing, what the velocity you will see? Right, it is at rest, the monkey is moving with the speed 20 meter per second, but the train is also moving with 50 meter per second. So this velocity is added 50 meter per second. What is the resultant? 30 meter per second. So with respect to ground, what is the velocity of monkey? Say 30 meter per second in forward direction. So in this way also you can solve this type of the question, right? Copy this. So now we start the relative motion in 2 dimension, right? Although the concept of the relative motion, what we have discussed in the 1 dimension motion, we will use the same concept, right? In here in the motion, relative motion in 2 dimension or in a plane, right? For example, suppose we have the 2 car, right? Suppose this is the car A. This car A is moving in the, suppose this is the east, west, the north, and this is the south, right? So it is moving in the east with 30 km per hour, right? And this is the car B, right, which is moving towards north with the speed 40 km per hour. Is it clear or not? Right. So now they will ask to find the relative velocity of car A with respect to B, and they may ask the velocity of B, right, velocity of B with respect to A. Is it clear or not? For example, suppose initially, right, this is the car B and it is at origin, right, and it is moving with 40 km per hour, right? So here, right, you have to find first the velocity of A with respect to B, and the second part is velocity of B with respect to A. You may also ask, right? So how to solve this question solution, right? The general way how to solve this question using the vector, right, assuming x-axis and y-axis towards east and north. So what is the velocity of A? In the vector form you will write 30 I cap kilometer per hour, and what is the velocity of B? You will write it is 40 j cap kilometer per hour. Is it clear or not? Now in the first case, velocity of A with respect to B, what is this? This is the velocity of A with respect to velocity of A with respect to B. Is it clear? Right. Okay, what is the velocity of A with respect to B? Mean velocity of A minus velocity of B. What is the velocity of A? 30 I cap minus 40 j cap. So this is the velocity of A with respect to B. What does it mean? With respect to B mean, this is the figure. With respect to ground, you will say, right? With respect to ground, it is moving in this way and towards north. But if you want to make the figure with respect to B, then this is the car B, and you will assume if you are sitting over here and you are observing the car A, understood? So this is the east, this is the west, north, and this is the south. And the figure with respect to B, you are observing the A, so it is at rest, fine, and the A is moving with this speed. What is that speed? It is 30 I cap in this direction and minus 40 j cap. This is the x-axis, this is y-axis. So what is j cap? Like this. So it is moving with 40 j cap in this direction. So what is the resultant velocity? This is the resultant velocity, right? So with respect to A, the car is going like this. The B is at rest and the car A is moving in this way. And what is this direction? What is the magnitude? Suppose this is the 30, this is the 40. So when you make 30 square plus 40 square is equal to 50 kilometer per hour. 50 kilometer per hour. And how to write the direction? Listen one thing. This is 30, this is 40, and the resultant is 50. This angle is 53. I think you understand. This is the 53 degree. So this angle is 53 degree. So what will you say? The magnitude of velocity A with respect to B is 50 kilometer, right? And what is the direction? This is east, west, north, south, right? This direction is south, 40 minus 40 j cap, right? So this is the magnitude. The velocity of, this is the magnitude, although this is the vector form, but what will you say? Velocity of A with respect to B is, right, 50 kilometer per hour. And what is the angle? At 53 degree, right, south of east. Is it clear or not? 53 degree south of east. This angle is made with the east. All right. Okay. Now in the second part, the velocity of B with respect to A. Velocity of B with respect to A. VB vector minus VA vector. So what is the VB vector? 40 j cap minus 30 I cap is equal to minus 30 I plus 40 j. What does it mean? This is the velocity of B. Velocity of B with respect to A. It means A is at rest and B is moving with this velocity. So when you are sitting, suppose at A, right? So it is at rest. You are making the figure with respect to A. Suppose this is the east, west, this is the north, and this is the south. Is it clear or not? Now, when it is at rest and you are observing the B, right? When you are observing the B, the velocity of B with respect to A is minus 30 I. If this is the x-axis, this is the y-axis. So this is the minus 30 I, right? And plus 40 j. So with respect to A, the car B is moving in this direction with resultant velocity 50 kilometer per hour. Is it fine or not? So it is moving, it is at rest and it is moving like this. Are you getting by what speed it is? Say 50. And what is this angle? You tell. This angle is 37 degree and this angle is 53 degree. So what will you say? The velocity of B, right? Velocity of B with respect to A is 50 kilometer per hour. Are you getting? At angle 37 degree, right? And this is north of west, 37 degree, west of north. This angle is made with the north, right? 37 degree west of north. Is it clear or not? Listen one thing. This is the relative motion, right? Although with respect to ground, it is moving in this way, fine. But with respect to A, it is moving in this direction. And with respect to B, it is moving in this direction, right? This is the direction. So with respect to B and with respect to A, when you will observe this car, so it is moving in this direction, right? When you are observing this, moving this car, This angle will be what? Say 53 degree. This angle will be what? Say 53 degree. Like this, like this. This angle is 53 degree. Are you getting or not? So this is the relative velocity. The relative velocity of one car is in just opposite to the relative velocity with respect to other car. Is it clear or not? Copy this. So listen one thing. Although this is the vector method, right, to to get the relative velocity, but we have the shortcut also. The same shortcut we have discussed in the relative motion in one dimension. We can use this. Let's see how does it work, right? Okay, listen one thing. First, we have to find the velocity of A with respect to B, right? Velocity of A with respect to B. With respect to B mean B is to be at rest. With respect to B mean you are sitting on B and observing the car A. So what you have to do to get the relative velocity of A with respect to B, this is the velocity of B is transferred to the A in opposite direction. That's it. So this is the 40. This is the 40 kilometer per hour, right? And this is the 30 is as it is. It is moving with that. So what is the relative velocity of A with respect to B? It is the 50 kilometer per hour. And what is this angle? 53 degree. You can get the answer easily, right? In the same way, if you want to find the velocity of B with respect to A, if you want to find that, right? Velocity of B with respect to A mean you will sit on A, fine, and you will observe the B. Are you getting or not? Right. So although B is itself moving with 40 kilometer per hour, fine, to get the relative velocity with respect to A, what you have to do, this is the velocity is transferred to the B in opposite direction. This is the 30 kilometer per hour, right? So what is the resultant velocity? It is 50 kilometer per hour. What is this angle? This angle is 53 degree. This is 30 kilometer per hour. Easy. It is moving like this. It is moving like this. So this is the simple way, and we will solve most of the question or all the question with the help of this, right? Copy this. So in this question, a man A moves in the north direction with speed 10 meter per second, and another man B moves in east, right, 30 degree north from towards north from east, right, with 10 meter per second. Find the relative velocity of B with respect to A. First of all, the meaning of E 30 degree north. Its meaning is 30 degree towards north from east. Are you getting or not? This is the meaning of this thing. So in this question, what we have, the man A moves in the north direction. It is east, west, north and south. So this is the man A is meaning with towards north, right? This is the man A, 10 meter per second. And what is the man B? Another man B. You can assume the man B anywhere. This is the man B, suppose, and it is moving 30 degree towards north from east, right? From east, 30 degree from east towards north. So this is the man B, and it is moving with 10 meter per second. This is the east and this is the north of this person. Is it clear or not? So what we have to find, the relative velocity of B with respect to A. Is it clear or not? So it is simple. So what we will do, its velocity is what? Say 10 cos 30 in this way. This is 5 root 3, right? And this is the 10 sin 30. What is this? Say it is 5 meter per second. So this is the figure with respect to ground. Fine. Now we have to make the figure with respect to A, because velocity of B with respect to A. So A is at rest and this is the person B. although it is moving with 5 root 3 in this direction, 5 meter per second in this direction. To find the relative velocity with respect to A, it is assumed to be at rest and its velocity is transferred in opposite direction. So this is 10 meter per second. This is 5 meter per second. Is it clear or not, you tell? So now what is the resultant velocity? If this is 5, this is 10. So the resultant velocity of this will be 5 root 3 as it is, and 10 minus 5, 5. So what is the resultant velocity? When you will simplify, right, it will be equal to what? Tell me. Is equal to 5 square plus 5 root 3 whole square is equal to 5 into 2 is equal to 10 meter per second. So this resultant velocity will be equal to 10 meter per second, right? It is moving in this way, 10 meter per second, and this angle is what? Suppose theta. So what is the tan theta? Is equal to 5 upon 5 root 3 perpendicular upon base. It is 1 upon root 3. All right. It is tan 30 degree. So theta is what? 30 degree. All right. So with respect to A, this is the A, this is the person B. With respect to A, the person is moving like this, 10 meter per second. Now what is this angle? 30 degree. It is east, west, north, south. What would you say? 30 degree, right? 10 meter per second, 30 degree towards south, towards south from east, or you will write 30 meter per second east, 30 degree towards south, right? It may be written as, sometime it may be written as 10 meter per second 30 degree, right, or south of east, right? It is making angle with 30 degree. So this is the velocity of B with respect to A. Is it clear? Copy this. So in the next question, A and B are moving with the same speed 10 meter per second in direction 30 degree towards north from east and 30 degree towards south from east, right? 30 degree towards south from east. Find the relative velocity of A with respect to B. So in this question, we can assume this is the person A, suppose, and this is the person B, you can assume. This is the east, west, north, right, and this is south. Velocity of A is 10 meter per second, 30 degree towards north from east, right? From east, 30 degree. From east towards north, 10 meter per second. If you resolve this, this is 10 cos 30. 10 cos 30 is how much? You tell. 5 root 3. And this is the 10 sin 30. And it is equal to 5 meter per second. Is it clear or not? And what is the velocity of B? It is velocity of B, it is 10 meter per second, 30 degree towards south from east, right? From east mean from east, and this is south, east, west, north, south. This is for person B, east, west, north, south, 30 degree from east towards south, right? This is the 10 meter per second. So this is 10 cos 30, mean 5 root 3, and this component is what? Say 10 sin 30, it is 5 meter per second. Is it clear or not, you tell? Now, this is the figure with respect to ground. But what you have to find? You have to find the velocity of A with respect to B. Is it clear or not? So, velocity of A with respect to B mean, what does it mean? Suppose this is the person B and you want to make the figure with respect to B. It means It is at rest, but the person A has already the velocity component 5 meter per second in this direction, and this is 5 root 3 meter per second in this direction. Fine. So to find the relative velocity of A with respect to B, what will you do? You will transfer the velocity component of the B to the A, but in opposite direction. If this is the 5 root 3, it is transferred to the A in this direction. So this is the 5 root 3 meter per second. And this is 5 meter per second, it is transferred in opposite direction. So this is 5 meter per second. Is it clear or not? The 5 root 3, it will cancel. So with respect to B, and this is the person A, moving with 5 plus 5, it is 10 meter per second. What is the direction? It is east, west, north, and it is south. It is clear or not? So what is the velocity of A? Velocity of A with respect to B is 10 meter per second towards north. This is the easiest way. No velocity vector, right, I cap, j cap is included, and this is the best way to solve the tough problem also, right? Copy this. So this is the question. Next example, two bodies A and B 10 km apart such that B is to the south of A, and A or B start moving with the same speed 20 km per hour eastward and northward respectively. Then you have to find first the A part, velocity of A with respect to B, minimum separation attained during the motion, time is elapsed from starting to attain the minimum separation. This is a very common question and it is asked many times in the NEET and JEE as well as, right, as well as JEE, right? So we will solve this question in a very simple way and you can understand this. Suppose we have the two bodies, this is east, west, north, south, and 10 km apart. B is to the south of A. This is the B, right? This is the person B, you can assume this is the person B, and this is the person A, all right? And what is the separation between them? Say 10 km, and B is to the south of A, right? This is the south direction and 10 km apart, and both are moving with 20 km per hour. It is moving towards east, fine, and it is moving towards north. Is it clear or not? You tell, right? This is the figure, this is the initial separation 10 km, right? This is the figure with respect to ground. Is it clear or not? You tell. Now what you have to tell, you have in the first part you want to make the velocity of B, velocity of A with respect to B. Velocity of A with respect to B mean, suppose this is the A and this is the B, right? This is A, this is B. With respect to B, it means it is to be at rest, tell me, and it is already moving with 20 km per hour. So to find the relative velocity of A with respect to B, its velocity is transferred in the opposite direction. So this is 20 km per hour. So what is the resultant velocity? Tell. The resultant velocity is like this. It is 20 root 2 km per hour. So with respect to B, it seems that it is at rest and the body A or the person A is moving in this direction. Is it clear or not? So what will you say? Velocity of A with respect to B is, right, 20 root 2 kilometer per hour, right? And this angle will be 45 degree if you understand, right? It is 20, tan theta. Tan theta will be what? 20 perpendicular upon base is equal to 1 is equal to tan 45 degree. Theta is 45 degree. Is it clear or not? You tell, right? So this is 20 root 2. is 20 root 2 kilometer per hour in, what is the direction? It is east, west, north, and this is the south. It is the southeast direction, in southeast, when the angle is made the 45 degree, right, in between the east and south. So it is called the southeast direction. Is it clear or not? Right. So this is the first part. In the second part, what they are asking? They are asking the minimum separation between the A and B. Listen one thing. With respect to B, if you suppose B is at rest, you will assume it is at rest. We are doing the relative motion, although this person is moving in this way, this person is moving in this way. After some time, with respect to ground, the person will move here, the person will move here. After some time, it will move here, it will move here. After it is moving in this direction, it is moving in this direction. Do you understand or not? But with respect to B, with the help of the relative motion, it is at rest always, and this is the person, it is moving in this direction. Initial separation is 10 kilometer. Are you getting or not? And this will be the minimum separation between them. This particle or the person A is moving with 20 root 2 kilometer per hour. Is it clear? This angle is 45 degree. I told you. If this is the initial separation, what is the minimum distance you tell? Suppose I am assuming this is the y, right? So tan 45, this is sine 45. Sine 45 is equal to perpendicular upon hypotenuse. This is the hypotenuse. 1 by root 2 is equal to y upon tan. Tan upon root 2 is equal to 5 root 2. 5 root 2 kilometer is the minimum separation. This is the minimum separation, right, between A and B. Listen one thing. Actually, when the person A is over here, right, the person A is over here. Is it clear or not? So the person move like this. So this is the separation. If it move in this direction, it move in this direction, right, then it is the separation. So initially the separation is 10 kilometer, then separation decreases, and again when it move over here, this is the separation. When it move over here, the person is over there, right, this is the 10 kilometer. Again the separation is increasing. So it is very tough with to solve this question, to find the minimum separation with respect to ground, right. We can solve this question also by the differentiation, but with the relative motion it is very simple. How? With respect to B, only the person A is moving. When it will be at minimum, initially separation this, when it come, this is the separation, this is the separation. So minimum separation will be at this position when it makes the angle 90 degree, and then the separation is increasing. So this is the minimum separation between A and B. This is the one thing. In the third part, they are asking the time from here to here. All right. So this is the person A, it is moving in this direction with this speed. Can you find this displacement x from point A to point B like this? Cos 45 degree is equal to base upon hypotenuse root 2 x upon tan is equal to tan upon root 2 is equal to 5 root 2 kilometer, right. So from here to here, the distance is equal to speed into time. So time is equal to distance upon speed. What is the distance they covered? They covered 5 root 2, and by what speed they are moving? 20 root 2. It is 1 by 4 r. 1 by 4 r mean 1 by 4 into 60 is equal to 15 minutes. So after 15 minutes, the person A and B are at the minimum separation, and the minimum separation between them will be 5 root 2 kilometer, right. Copy this.